On December 18, 2024, the United States Geological Survey quietly raised Mount Rainier to the top rank of its National Volcanic Threat Assessment. Not Mount St. Helens, not Kilauea. Rainier. The press release was 3 paragraphs long. It did not mention new eruption activity. It did not mention rising magma or seismic swarms. The reclassification was based on something else entirely: new population data, new infrastructure exposure, and revised inundation maps that now show roughly 150,000 people living inside a zone that could be buried within 60 to 90 minutes of a collapse. Because here is what makes Rainier unlike any other volcano in the lower 48. It does not need to erupt to kill a city. Mount Rainier's summit holds 25 named glaciers and more than 8 billion cubic meters of frozen water. It's the largest glacial system on any single peak in the continental United States. When that ice meets eruption heat or a hydrothermal collapse, it doesn't melt. It detonates. The result has a name that geologists speak carefully: lahar. A lahar is a volcanic mud flow, a slurry of water, mud, and boulders moving at freeway speed with the density of wet concrete. It doesn't flow like water, it flows like liquid rock, grinding everything in its path and setting like cement when it stops. Rainier has produced more than 60 lahars in the last 10,000 years. The largest was the Osceola mudflow. About 5,600 years ago, it traveled 120 kilometers all the way to Puget Sound. The deposit from that single event can still be seen in the soil beneath Kent, Auburn, and parts of the port of Tacoma. You stand on it every time you drive down Interstate 5. The town of Ortang, population roughly 9,000, sits directly on top of that deposit. Sumner, Puyallup, Kent, Auburn, Tacoma. All of them sit downstream of a mountain that has buried the same valley at least 16 times since the end of the last ice age. The rock is already rotting. The timeline that matters for Rainier is not eruption history. It is structural. Rainier's summit cone has been severely altered by millennia of hydrothermal fluids. Sulfuric acid and steam from the volcano's shallow magma system have been slowly eating the rock from the inside out. A 2001 USGS field survey mapped a zone of more than 200 million cubic meters of weakened clay-rich rock on the upper flanks, the kind of rock that behaves like saturated pottery. It does not need an eruption to fail. It needs a trigger, a shallow magmatic swarm, a small phreatic explosion, or simply a large enough earthquake on the Seattle Fault, 70 kilometers to the north. Any one of those, and the upper flank starts to slide. Within 10 minutes, the mass has entrained the glaciers. Within 20 minutes, it is moving down the Puyallup River Valley at 80 kilometers per hour. Within 40 minutes, it reaches Orting. Within 60 to 90 minutes, it enters the outskirts of Tacoma. That's not a projection. That's the timeline from the 2019 Pierce County Emergency Plan. It's also the timeline every elementary school in Orting now drills against. 5 rivers, 5 population centers. The geography focuses the threat. Mount Rainier stands 4,392 meters above sea level, roughly 85 kilometers southeast of downtown Seattle and 60 kilometers east of Tacoma. 5 river valleys drain the mountain: the Puyallup, the White, the Nisqually, the Cowlitz, and the Carbon. Each of these rivers funnels directly into population centers. The Nisqually passes through Joint Base Lewis McChord, a military installation with 40,000 personnel. The Puyallup passes through Orting and Sumner before merging with the White and emptying into the port of Tacoma, a facility that handles more than 3 million containers a year, and is one of the primary West Coast gateways for imports and exports. A lahar reaching tidewater would not just bury people, it would shut down a sector of the national economy. The warning system isn't working. Here's what isn't making headlines. The monitoring system that is supposed to warn those 150,000 people is a distributed network of acoustic flow monitors, seismometers, and tripwire geophones installed along the river valleys by USGS and the University of Washington. The system was originally designed in the 1990s. In 2022, an independent audit by the Washington Military Department flagged that more than 30% of the sensors were offline, out of date, or communicating only intermittently. The replacement budget was approved. The installation schedule has slipped twice. Dr. Kate Allstat at USGS, who has worked on the Rainier detection network, wrote in a 2024 briefing memo that the current system gives residents of Orting approximately 40 minutes of advanced warning under optimal conditions. In a power outage, 40 minutes drops to under 10 minutes. In a seismically triggered collapse at night, she acknowledged the first warning might be the sound itself, the children who drill for it. On a Thursday morning in November 2019, a first grade class at Ptarmigan Ridge Elementary School in Orting practiced what the Pierce County Lahar drill calls beat the bridge. At 9:47 in the morning, teachers walked every child in the school, 412 children, kindergarten through 6th grade, up a hill behind the playground and into a waiting line of school buses. The children carried red emergency bags. The buses drove them 2 miles uphill to a designated evacuation point near the Voigt Creek Bridge. The drill took 44 minutes from start to finish. The operational target, based on the mountain's geology, is less than 30 minutes. The teachers who led the drill did not tell the first graders what they were practicing until the end. The district policy is to keep first graders from knowing what the mountain has done before. These are RONC projections. These are the current operating numbers at the U.S. Geological Survey Cascades Volcano Observatory. 8.5 billion cubic meters of glacial ice. 200 million cubic meters of hydrothermally weakened rock. 150,000 people inside the inundation zone. 60 to 90 minutes to Tacoma. 40 minutes of warning under optimal conditions. $1 spent on Rainier monitoring for every $4,000 of real estate sitting in the lahar zone. Rainier last produced a lahar of sufficient magnitude to reach Orting around 500 CE. Geologists have documented at least 2 other large lahars reaching Puget Sound in the last 5,500 years. That is a recurrence interval of roughly 1 every 500 to 1,000 years. Rainier is now 1,500 years past its last major lahar to Orting. Nobody can give Orting a date. The Cascades Volcano Observatory operates a real-time seismic and deformation feed 24 hours a day. The tremor rate at Rainier Summit has been low for most of the past decade. But in the last 18 months, there have been 3 shallow seismic swarms recorded above 1,800 meters in elevation. The U.S. Geological Survey has not yet flagged any of them as magmatic unrest. Dr. Seth Moran, scientist in charge of the U.S. Geological Survey Cascades Volcano Observatory, said in his most recent annual briefing that the system is stable but trending, and that the relevant policy question is whether the inundation zone warning infrastructure is funded before, not after, the next event. Which leaves 3 questions. If the detection network depends on geophones that are offline 30% of the time, what is the real warning window for the 9,000 residents of Orting? If the last lahar reached Tacoma in 500 CE and the recurrence interval is 500 to 1,000 years, what number is Rainier currently on? And if a Seattle fault earthquake can trigger a flank collapse without any eruption at all, how does a city evacuate for a volcano that has no eruption in progress? Somewhere on Rainier's south face right now, sulfuric steam is still eating rock. The glaciers on the upper flank are still flexing against it. The Puyallup River is still running cold and clear through Orting. And the mountain that has buried this valley 16 times is still 4,392 meters tall.